welcome to 7.4, the reciprocal of a function. Just talking a little bit about what a reciprocal is. A reciprocal is basically putting whatever number under 1. And I know that sounds a little bit confusing. They give the example of, 3/4 is the reciprocal of 4/3. I'd like to show how that happens. So I'm just going to give an example using f of x. So if f of x was equal to 3/4, then 1 over f of x would be equal to 1 over 3/4, right? Recognizing that this f of x can be replaced by the number 3/4 is how we do that. Now, above, it does say that, 3/4 is the reciprocal of 4/3, and 4/3 is the reciprocal of 3/4. But the way that we get there is that if I'm dividing 1 by a number, then 1 over f of x is going to become the numerator, which is 1, multiplied by the reciprocal of the denominator. So we would have that 1 over f of x was equal to 4/3. Now, the reason we care is, just as a quick example, this is a general idea that the value of the function is 3/4. But what if we said the function f evaluated at 1 is 3/4? Well, really what we're saying is that 1 comma 3/4 is on the graph of function f. Now, we can make a very, very similar statement with what I did over here. So I'm going to say that 1 over f of 1 is equal to 4/3. Now, what that means is that 1 comma 4/3 is on the graph of the reciprocal of the function. And that's going to be really important. That I just want to grab a couple points, and I'm just going to make these up. So say we knew that 1 comma 6, 3 comma, we'll make 0.1, a very small number, and then just the other example we're going to run into, which is 5 comma 0. If those are on the graph of f of x, then on the reciprocal, what's going to happen, and this is confusing for a lot of students, is that the x isn't changing. The result of putting that x value into the reciprocal function is what's changing. And it's very, very important that this is nothing more complex than saying 1 comma 6 turns into 1 comma 1/6. Now, 1/6 is an ugly decimal. It's repeating, as you can write as a fraction, but I would recommend starting to recognize that if we have a nice big whole number, then the reciprocal is just 1 over that whole number. Now, where that gets a little trickier is with decimals. So if I look at 3 comma 0.1 on the reciprocal, I'd have 3 comma 1 over 0.1. Now, as a general rule, if we can simplify points, we should. So I should write this as 3 comma 10. Now, this is highlighting a behavior that we're going to talk about as we actually work through the notes, that the larger the y value of the function, the smaller the y value of the reciprocal. And the reverse of that is true as well. So in this first point, 1 comma 6 has a relatively large y value. On the reciprocal, we have a pretty small y value. It's pretty close to 0. My next point, my y value is 0.1. Look at the y value on the reciprocal. It's positive 10. And that would get more extreme. If I took the point, just 10 comma 0.01, when I take the reciprocal of that, it's going to turn into 10 comma 100. Or if we looked at 10 comma 0.001000, 0.001, that is going to turn into 10 comma 1000. So when we talk about that reciprocal, if the original function is approaching 0, the reciprocal of that function is actually going to go up or down to infinity. We'll examine that further in the notes. We'll actually do a nice table of values to see exactly how that happens. I'm going to put one more point on here. 7 comma 1, but let's deal with 5 comma 0 first. If I take the reciprocal of that, I get 5 comma 1 over 0, and this is a problem. You cannot divide by 0, so this point doesn't exist, and it's undefined. And that's going to be something that's very important, that the x-intercepts of the original function become what we call vertical asymptotes on the reciprocal. And the logic behind that is, if we have an x-intercept on f of x, the y value is 0. And you cannot take the reciprocal of 0. All right, the last point I'm looking at here, 7 comma 1 would turn into, and I'm going to write it like this, it'd be 7 comma 1 over 1, which is still 7 comma 1. And these 2 points, the ones that I'm putting an asterisk beside it, are going to be really useful, because when we graph f of x through inspection or just by looking at it, we're probably going to be able to identify where we have vertical asymptotes and where we have something called, I'm going to write it beside, this is what we call an invariant point. And the reason we say that is because if we look at f of x to 1 over f of x, that point doesn't change. That point's on both graphs and it's the exact same location. So we say it's invariant because it didn't vary. So there's a nice little bit of logic in the word behind that. Oh, I forgot to write point, sorry. All right, so this is just the instructional video. We're going to get into those examples to try to highlight some of this. One thing I'd like to talk about before I go anywhere is make sure you have your calculator. Your calculator is a very, very useful tool in graphing these, although it can make little mistakes because it is just technology.